Alright, so this is Mr. Jacobson. This is my first attempt at using what is called a flipping the classroom strategy, and if you guys are watching this, then it seems to be working. And what we're going to be doing is exploring today how atoms combine and why they combine. If you look at the periodic table, such as what you should see here, if I can get this to paste in correctly, we had this table, and this table we've seen before. It's the periodic table, and with this periodic table you'll notice that we have very many different columns that we call families or groups. If you look at group 18, it says that the charge over here is 0 because these are the noble gases. The noble gases are already happy the way that they are. They have all the electrons that they could possibly want. And electrons are really the driving force when it comes to what we're going to be talking about with bonding. And we can see group 1 has a +1 charge, group 2 has a +2 charge, group 13 has a +3, group 14 can either be 2 or 4, and we'll talk about how we can tell if it's 2 or 4 once we get there. Group 15 always has a -3 charge, 16 -2, and 17 is -1. We're not going to worry about these guys down here or what are called the transition metals in here because they get a little bit confusing, and so we're just going to kind of ignore these and these for right now. Alright, move those off. Now, we said that electrons and these oxidation numbers on this periodic table are what we really are going to worry about. So, if we look here, I'm going to pull this down, I'm going to try and say, okay, if you have a normal periodic table in front of you, you'll see that sodium is in group 1A right here. So we know that sodium, by looking at this table, that sodium has a +1 charge that it makes as its oxidation number. And you'll want to memorize these charges. These are things that you will be using so many times between physical science and chemistry that you want to be making sure to memorize what you see here on the periodic table. Alright, move that back up there. So, if we have sodium, Na, and sorry about the horrible handwriting here, I'm trying to use my mouse. So we have sodium chloride, sodium, Na, and we said that sodium is going to have a +1 charge. Okay, because from this periodic table we know that it's in group 1, so it has a +1 charge. Alright, now if we look at this periodic table again, if I can find the right tool here. Okay, so if you look, we've got this periodic table back out, and if you look at yours in your book, which you should have in front of you, you'll find that chlorine is in group 17. Group 17 always has a -1 charge right here. So we know that sodium has a +1 charge that it's going to make, and chlorine is going to have a -1 charge. Now, if we look at how those are going to bond together, so we have Na there with a +1, just saying, and then chlorine, Cl, has a -1 charge. So we've got +1, not just plus. So +1 for sodium, -1 for chlorine, and we want to figure out what is the formula that is going to be made from this compound. Well, the formula that's going to be made has to equal 0. This one works out perfectly because we see we have a -1, we have a +1, and in your books we talk about, and earlier before we've talked about the crisscross method. The crisscross method takes this charge, this number right here, and what it does is it puts it down below and to the right of chlorine. And then you take this number here and you put it down and to the right of sodium. So if we took another example, let's erase everything here. Whoa, bright red. Didn't quite mean that one. Okay. Going to erase everything that we've got, delete this, get back our color that we wanted. Alright, so if we take another example really quickly, I've got about 30 seconds. I'm going to say that I have calcium with a +2 charge. I know it's a +2 from that periodic table that we had before. And then I know that I have chlorine, and we said that chlorine before was a -1. So if it's a -1, we crisscross these, and we end up with Ca1Cl2. Thank you for watching.